Hi, this video is about ground planes on PCBs, especially for people, but not limited to people that use, like me, Abacom SprintLayout for editing their PCBs. Ground planes. A lot of people ask not really what a ground plane is, some also do that, but or especially what to use it for. Why are ground planes used on PCBs? And there are mostly two reasons. Reason one is shielding. When you have tiny signals on your PCB, digital or analog, and you want to shield them from outside sources like RF, or also from other circuits on your board. Maybe you have an area on your board where you have a switching power supply or something like that, and you don't want those signals interfering with some finicky control circuitry. Then a ground plane would be a good way to isolate them a little bit from each other. And also sometimes between pins, when you have RF circuits, etc., they are mostly shielded with ground planes on both sides, so they are not influenced by other parts of your circuitry, but also from outside sources. So shielding is one reason, and the other reason for using ground planes is, of course, saving traces. This is a small example I just drew up on SprintLayout. That's nothing that I'm going to produce. Is just for this video. That's a simple layout, and you can get away with lanes like that to connect everything to ground. It's not pretty, don't judge me by that. It's as I said, it's just drawn up for this video. But on complex layouts you sometimes have problems with fitting all the traces on the board, and also when you use double layers, two layers, sometimes even then you have troubles with all the traces. And multi-layer PCBs, you can do multi-layer with 6 layers on with Abacom SprintLayout, but of course they are much more expensive to get produced. So a ground plane is a way to go on most boards, especially because it's free. You don't pay for ground plane. And also most PCB manufacturers like it when you use ground planes, because they don't have to etch away so much of the copper, because the raw material for PCBs is epoxy, FR6 mostly, which is totally covered with copper. So everything where you don't want copper, they have to etch away. And the more they have to etch away, the more their etching solution, their etching bath get saturated. So especially in the early days it was, and I think now too, PCB manufacturers like it, if you want to say it like that, like it when you don't, when you use ground planes and they don't have to etch away so much copper. But for you as a user, of course, it's the benefit of using ground planes, of course, is saving traces. A ground plane, you can activate a ground plane in SprintLayout. That's what this video is about. With this button, you have to select one of the copper layers. This is the top copper layer, that is the bottom copper layer. As you might notice, I'm using a German SprintLayout version because I'm from Germany. So I've selected copper layer 1, the top layer, and now I click this button for the ground plane. Then now you see everything is blue. There's not much black left. And by standard, there's a clearance from all your copper parts like pads, traces, etc., or vias like that one. That is a mounting hole on this PCB. There's a clearance between those things and your copper. So the black area, there is no copper. That will be etched away. So right now the copper layer doesn't do much, except for, as I said, the PCB manufacturer is maybe a little bit happy that they don't have to etch away that much copper, but you don't gain much. There's also not a real good shielding, because the ground plane right now, or the plane I should say, is not connected to anything, so there's not a defined level where this plane is. Now we want to use it as a ground plane, so we have to connect it also to the parts that should be connected to ground. Let's begin with this via. That's a soldering via, just a rectangular one. In the photo view you see that's the top view and the bottom view. That would be where you would solder a cable to this little PCB. There are 3 connections here. Let's connect that to ground. We can do this by 2 means. Option 1 is simply to not have the copper etched away around it. To do that we just select the pad, and here you have the clearance setting. That is how much copper is removed between this copper item, the solder pad or the via in that case, and the ground plane. And we could simply now put it to 0. Now that pad is connected directly to copper, so, or you could say it's just within this copper, and only in this area there's no solder mask, so you can solder on it. You can do it like that. That's one way to do it. It has some pros and some cons, but let's just for now I will show you the other way to do it. So let's get back, put back here our clearance. We can also make it connect to the ground plane as a thermal pad. You select it, then you go to the property page, you open it if it's not open already, and then you have a little checkbox that there's a thermal pad after you selected it. Let's check this one, and now you already see 4 connections from this pad to the ground plane, but there are still some areas where the copper is etched away. And with this, I always call it a selection star. This is where you can select where the connections are going from this item to ground plane relative to the PCB, top, bottom. So that's this connection right here. I can turn it on and off, or maybe I can say, oh, I only want the top and bottom connection, and I also can adjust how wide this very short trace would be. So that's the other way to do it. The difference is with just setting the clearance to 0, I can even do it if it's still selected a thermal pad. Of course I have the best possible connection to ground. We also of course have to remove that trace. But it has one disadvantage, and that is copper of course is a very good heat conductor, and when you're soldering in this case a wire to that pad, in this configuration you would take quite some seconds, maybe longer, to solder a wire on this pad than on that one, because all the heat, or a lot of the heat, will be sucked away into the ground plane, because it's the copper goes on, and there's no isolation, I would say, because the epoxy of the PCB is not connecting heat very well, but of course the copper is. On some cases like here, that would be a wire which you would hand solder mostly. It should not be a problem, so we could leave it at that. But on SMD components, you of course don't want to put your soldering iron on there for too long, or if you are soldering with solder paste and hot air reflow the PCB, there can be problems with so-called tombstoning. That is when the SMD part, like a resistor or a capacitor, it only happens to small parts. When you have set this one pad, maybe directly to ground, with no clearance, and you remove that one, of course that pad will get hotter by the hot air first, because here you also have to, a lot of heat goes away into the copper of the PCB. So that copper, the solder paste on this side of the capacitor would melt first, and it can like pull the part up on this side. So it's like a tombstone on a grave. It will stand up slightly. So you have to rework that part. It mostly when you do it by hand reflowing, you can observe it, and I have to say with parts like 0608, there's an 0608 resistor, it did not happen to me until now. But I would say with 0603 or 0402 components much more smaller, the chance is much higher. So the way to go would be not, let's go back a step, would not be to directly connect it to the ground plane by removing the ground plane clearance. We should make this a thermal pad. And of course this is a macro. This is one part from the part library. And if you want to edit just one of the pads, of course only this one should connect to ground. You don't have to disassemble the macro in SprintLayout. You can just press and hold the Alt key on your keyboard and then left click this pad and release, of course. Now this one is selected, and now we can only for this of the two pads we can select thermal pad. That way you can also alter some other items, like this of course is a macro too, and you can, if you would want this outer line, if you would want it wider, you don't have to disassemble the macro. You also could hold the Alt key, in this case double click, or no, one click on it, and then you could do something like that and play around. Once you click away somewhere on your PCB, it's still one macro. You just edited that one part of the macro. So we will do this. Also this one pad also should be connected to ground. So here we also press the Alt key and click on it, and we select thermal pad. But here you see that especially this connection does not make any sense at all. So we can remove that one. We also might maybe turn down the clearance to 0.3. That's a clearance that's usually good for manufacturers, but now you see this SprintLayout has a very easy mechanism. Everything which is not in this 0.3 millimeter range is flooded with copper, and then sometimes you get very tiny traces like these, and they cannot be manufactured by your PCB manufacturer. They either will look it over, and it can happen that this very fine trace could disconnect while etching and like connect to something else, like a hair that's on the PCB, and then when they add copper, because they usually first they etch and then the remaining copper is very thin, they add copper on top, then you can have bridges, but most likely your PCB manufacturer would reject that board. So in this case 0.4 was better, because then you won't have these effects. Okay, so still we want to edit it. Press Alt and click. We want it a little wider, won't we? Yes, we want. So now also Z pad. Press Alt, one click, thermal pad. Here maybe it doesn't make sense to go to 0.3 millimeters of clearance. Let's delete this trace, it's obsolete now, because that's connected to ground. Also this side of the LED will be connected to ground, of course. So that's a thermal pad as well. So now we don't have any ground traces on this PCB. If everything is connected via thermal pads, so soldering is not such an issue. Yes, that's a good thing. That worked quite fine. That's how you do like this. You can, as I said, either connect it by setting the clearance to 0 or by using a thermal pad. These mounting holes, it depends on whether you, in that case, want to have them grounded or not, but maybe we won't. So mounting holes, I would always not use thermal pads. I would, if they should be connected to ground, I would always put the clearance to 0. Because usually you don't solder on them, so there's no question about it. Because of course setting it to 0 is a better grounding method than this one, but you do it here because usually you don't have too much of a current here. But you so it's good to enjoy the benefit of easier soldering because you don't take all the heat away. That's why it's called a thermal pad. Yeah, so these are the two ways to connect anything to the ground plane, either by setting the clearance in here to 0 or by setting something to be a thermal pad. But of course there can be some problems with ground planes. We observed one in here when we set the clearance for that part. It's part sensitive, of course, this setting here, to 0.3 millimeters. Then of course we have these effects, so you must avoid those. There's always a minimum copper width that your PCB manufacturer specifies, and usually it's around 0.2 millimeters. That's normally always a safe level. Mostly it's even 0.15 millimeters, but I always go with 0.2. As you might know, Abacom SprintLayout has a design rule check, and here I also have a minimum trace width or copper width of 0.2 millimeters. But there's one, you could say, flaw in the DRC of Abacom SprintLayout. If I set the clearance here to 0.3 and I end up with these tiny traces, let's measure them. Of course, measuring always it normally always jumps into the grid, but by pressing Control and holding Control, you avoid the snapping to the grid. So let's measure this tiny trace. It's 0.31 millimeters, 0.3 around. So that's definitely not manufacturable. So what does our design rule check do? Nothing, because it in Abacom SprintLayout, that's one thing the design rule check does not really check, sadly, of course. So that's one thing you have to check on your own, that you don't have those tiny traces. There is a way around, of course. In here the trace is still wide enough. We can see 0.1, 0.2 millimeters, but let's say it would be too small. Then you could also exclude this area from ground plane. And you do it layer wise, that is on the copper layer 1, or the top layer, of course. And you could, here are like, oh, how is it called in English? You can define an area where there's no ground plane. Let's switch the grid to 0.1 millimeters, and you can either draw a rectangle or a polygon. Let's draw a rectangle right here with, of course, 0 width, and just draw it like that. And now, when I release the mouse, this area is now marked as not to flood with ground plane. You can click on it and then you see it, otherwise you don't. And that's how you can define areas where you want a ground plane exception, you could say. The other problem, or the last one I think, yes, the last one I think I've on my list is islands. You can end up with ground islands. You don't have it in here. Actually, there's not really an island on this layout. But if we would, maybe, let's revert back to 0.5 millimeters. Let's do it like that, and also put a little more clearance here. So here's no ground connection within the ground plane because the clearance is higher, or maybe I've drawn an exception area here. And now we have a little island of ground plane in here that is connected to nothing. It's not really ground plane, it's just it's also called floating copper. That's normally not good. The clearance for this via is set for both layers, also for the oh no, I did not enable auto ground plane for the lower copper layer. Now I have. So this ground plane, this via for connecting a cable, is connected to both sides of the PCB. And on the lower, we can check, this is the top side, that's the lower side. It's directly connected to copper. So on the downside, because we have no components or anything here, it's pure ground, except for these two pads. So what we can do to remedy an island like that, let's switch back to the top level, is to just use a small via, and usually, because you don't want them to waste space, you can usually go like 0.4 millimeters hole width and 1 millimeter outer width. Just take a round solder via and place it in here. It's a via. It's contacted through both sides. That's why it's bright blue and not just plain blue like the top copper layer. And on this via we set the clearance to 0. And now we have connected this island, which is not a real ground plane, which was floating copper before. We now have connected this by that via to the ground plane on the top layer, on the bottom layer, sorry. And that's how you can stitch all those islands together, because on more complex layout you will always end up with some islands here and there where you have floating copper. You don't want that. So you can always switch between layers and connect the ground planes together. Yes, I think that's mostly it for that video. I think so. Yeah, that's about it. So, ground planes. As I said, it's used for shielding and for saving traces on your design. To make it like that, it's much easier. You have much more space for other components, because you don't have to sneak in ground lane trace like that around here. So you could put much more components on your layout. It's easier. And also the test function, also now we can check what is all connected to ground. Everything we want, this pad, the IC pad, the LED pad, and our via, so we now know that this island is also ground. Yeah, I think that's about it. I hope it helps. If you had troubles or questions about ground planes, how to use them, why to use them, and especially how to use them in SprintLayout. Bye.